Hey, we're a little bit crooked, so just turn your head, and we'll just be fine with that. It turns out that we have been studying when a T procedure is robust against certain conditions. We are required to check RIN to make a confidence interval for any confidence interval, but for a particular T procedure, we're going to discuss the normal requirement. And it turns out we can be a little lenient about normality. Well, we know when n is greater than or equal to 30, there's no problem, because any sample, no matter what kind of population you start with, if n is greater than or equal to 30, the actual sample is normal anyway. So T procedures are fine. So we can use T procedures. But then there's these two other bands that are of interest. So what if our sample size was between 50 and 30? Then we can use T procedures, again, unless there are two things, and that is strong skewness or outliers. So if they are indicated in the problem, you say no can do T procedures. Otherwise, it is robust in this band between 50 and 30, and you can use T procedures even if it's not normal exactly. So remember that one with the device we put on the engine? We looked at the histogram and it was goofy. It was something like that, which was not normal. However, it had no strong skewness and it had no outliers. So we can use T procedures. We can fudge with them because they are robust against normal conditions unless these two things occur. And lastly, if n is greater than less than or equal to 15, T procedures are good as long as the data looks normal. When we say looks normal, from that low, it does have to be unimodal and symmetrical. So you do have to look, and when it's that low, it does have to look somewhat normal in order to use a T procedure. All right, so we went over that, and we did some examples and talked about those. Now we're on quiz 8.1a, and you wanted an extra one, right?
Yes.
Okay. All right, there's given out last night, there was 8.1a quiz that we're not using as a quiz, and 8.2a, and I only required you to do 8.1 so far. So we're going to go over the answers, and this is in review for our tests which we have scheduled on Thursday, reviewing all the rest of the day and all day tomorrow. And tonight I'll be giving you an exercise as well. So 8.1, all right, let's see if you can read it, Maggie, the whole thing to us.
A consumer watchdog organization estimates the mean weight of 1 ounce fun-sized candy bars to see if customers are getting full value for their money. A random sample of 25 bars is selected and weighed, and the organization reports that a 90% confidence interval for the true mean weight of the candy bars is 0.992 to 0.998 ounces.
All right, so from that they asked us what is the point estimate. So how are we going to get that from what is given? Ideas? Brian, what did you do?
I just got 0.995.
And how did you get that? It is correct?
I think I found the margin of error first, but that I subtracted the smaller number from the bigger number.
All right, and that tells me the length of the whole interval.
Yeah, then I divided that in 2.
Okay, that's exactly right. But
Then I subtracted that from the bigger number.
Okay, was there another step? I guess you're right.
You just had to average them.
Yeah.
that's what
Okay.
Well, I got that.
Another thing you could do, he did it correctly as well, just a little round the robin there, but if you add these two and divide by 2, you'll get the number right in the middle, and it is 0.995. So that's because when we have a confidence interval, right in the middle is the point estimator. In this case, it was 0.99, what was it, 5?
Yeah.
Okay. All right, so that was 1A. Now we had to go and find the margin of error from all that. So if this was one end right here, 0.992, and this was the other end, and this was the middle, where do I go in this discussion to find the margin of error? Bree, how's that pan out?
We did them on the board earlier, so wouldn't it be Z star
and then the square root of P1 minus P over
Right,
N.
but so we don't have all that information in this one. What you say is true. How can we glean the margin of error from what we are known in this one? Because the margin of error is always from the point estimator, the one side or the other. So how can we get that in this one? Because we have this point and this point, and we need this in between. All we do is find the difference. So we have to take this point A, part A was this one, and margin of error is going to be this amount right here from the point of estimate, which you got in part A, from the larger number. So when you did that, it comes out to be 0.003. And that, what are these? Pounds or something?
Ounces.
Ounces, okay. All right, that's small, 0.003 ounces. So that's the margin of error here.
You don't have to do the other equation at all.
I don't have all that information. I guess you could get Z star, but
It's because we already know the, we already know 0.992 to 0.998 is the confidence interval, right?
right, that's the confidence interval right
And so the
here.
other things that are like inside of that we can just find by,
Right. All right, so we always know that from the point estimate all the way up to one end and down the other end are both margin of error. All right, that was part B. Part C. Interpret a 90% confidence interval from that interval in the context of the problem. So now we just bring out our words. We are. Can you fill in what you wrote there, Joel?
I said we are 90% confident that the mean weight of candy bars is within the interval of 0.992 and 0.998.
All right, that's exactly right. All right, but when they say in the context, see how he brought out the words candy, weight of candy. So you gotta have to indicate the specifics to get all full credit for that. So you can't just say we are 90% confident that the true mean is in 0.992 to 0.998. You're gonna have to say mean of what? So in this case, the mean weight of fun-sized candy bars.
should we say the mean weight of the 25 fun-sized candy bars or just fun-sized candy bars?
In this case, we are 90% confident that the true mean of all candy
Okay.
bars is in that. So, I guess from that, is this a factory thing? I forget. No? Just all the fun-sized candy bars. All right. Part D, interpret the confidence level. So, we don't deal with this one as much, but when we learned it, I tried to emphasize it. So, what do you think on that one? Morgan, give it a try.
In 90% of all possible samples of size 25, the method would produce an interval that captures the parameter.
Yeah. Another way to say it, if the procedure was repeated many, many times, the intervals created would capture the true mean 90% of the time. Remember that day when you came up to the board and you all put in your confidence intervals? And they went like that? And we found out if we had done that for every single possible sample of size n, 90% of them would capture the true mean of the population. So again, if the procedure was repeated many times, the intervals created would capture the true mean 90% of the time. So notice the word chance and probability are not in either part C or D. I noticed when they set up tests, they like to trick you and put in stuff like, oh, we are 90%, it'll say, the probability is 90% that this interval will contain the mean. It's not a probability like that. It's a confidence, not a probability. So don't pick anything that has the word probability or chance in it, and you'll do well. All right, on number 2. All right, Joel, reread it to us.
Okay.
Wait, did you answer that last part again? You
Confidence
said don't
level.
take anything that has chance or probability in it?
Right.
Or confidence level?
Yeah, or confidence interval.
Or confidence interval.
Number 2.
All
A
right.
manufacturer of flashlights wants to know how well one of their newer styles is selling in a chain of large home improvement stores. They select a simple random sample of 20 stores, record how many of the flashlights were sold in a 30-day period, and construct a 95% confidence interval for the mean number of flashlights sold.
All right, we're supposed to discuss whether this study meets the conditions for constructing. So they're looking at RIN. So when we go down the list, R, was there a random selection? Joel, speak to that.
Yes, they
All right,
did.
I
yes.
saw the word random. Usually we do. And then what about independence?
The stores are independent of each other.
All right, and they did take a simple random sample of 20 stores, which is kind of confusing because from those stores they recorded how many flashlights were sold in a 30-day period. So if I do look at the independence of the store number, 20 times 10, is that less than the number of stores? I don't know how many stores there are. So another way,
Probably more than 200.
it all depends on what they are. All right, so we'll say assume. Okay. All
And
right,
it says
that's all we can
there's a
do.
chain of large home improvement
Yeah,
stores,
that's
so
true. I think they're
probably
trying to
says a lot.
tell us. Yeah, that's a good point. And a lot of times you'll see the word large in those statements. So they're trying to help us through the I part when they do that. So we'll say, all right, and now N. All right, Joel, what about normality?
Do we not know if it's normal or not?
Right. Right now, I don't see any indication that it is normal. If it came from an overall population that was normal, then we would assume normality. However, we weren't told any of that. So right now, normality is unknown. So then, it said, if one of the conditions is not met, how can we change things so that we could do the study? So Joel, what do you think?
You could make sure that the population is normal.
Yeah, you could do that. That's because we know if it comes from a normal population, any sample is, and I guess we can increase N. Even though that we were talking about, Joel, the number of flashlights, they went off of the number of stores.
Yeah, okay.
So if we're going to increase N. So if it was greater than 30 or 30 or greater, if N is greater than or equal to 30, then we could proceed. Because we know normality, because of the central limit theorem says, and remember all the ones we did on the computer, we started with, like, Andrew devised a population that was very strange, and we went to 25. When N was 25, we actually found that the sampling distribution was normal. So we went up, we even upped the ante and went to 30. And so if you get 30 or more, you know you have the normal sampling distribution, and you can use your confidence interval with confidence. All right, read B for us.
So we, it's not normal.
It's not normal, and it asks what additional information would be required, and there's two answers to that. We would have to know that it started from a normal population, or we could increase N greater than or equal to 30. We have two choices. All right, part B. Would you read that, Maddie?
If instead of constructing a 95% confidence interval, the flashlight manufacturer constructed a 98% confidence interval, would the 98% interval be wider, narrower, or the same width as the 95% interval?
All right, do you know how that works, Maddie?
Yeah, so it's like the bigger the interval is, isn't it? It's wider because you're more confident,
Right. So like Garfield, when he said,
Right.
the temperature is going to be between negative 200 and positive 200. So we are 100% confident in his statement because he made his interval so wide. So your confidence grows as your interval grows.
So when your confidence interval grows, what grows?
When your confidence interval grows, your
Confidence grows.
No, when the confidence level like 90% becomes 98,
Okay.
then the width of the interval grows.
Okay.
All right, how would the width of confidence interval change if the flashlight manufacturer took a larger sample? So that's another thing we discussed that same day. What happens to the size of the interval for larger n? Dan, what do you think?
This is C.
Yeah.
I'm not sure if this is right. I said when the sample size increases, the confidence interval decreases and gets narrower.
It does. Can you explain?
Well, if you have a set between these two numbers, but then you increase the are you increasing
sample
the
size?
sample size, then it would shift and or no, it
It
would.
says, I guess, in theory, the only thing I can say is the more number in your sample, the more information you have, so you can be more precise. You can zero in on that true parameter, and you can squeeze in and be more confident with a smaller band. But mathematically, I can understand it better, because what do you have up here? Right here, can you see this one? X bar plus T star S is samples, S sub x is the standard deviation from the sample divided by square root of n. So what's going to happen to the length of this thing if we increase n? So the number in the denominator is going to grow, so this whole number is going to shrink. So that's mathematically, you can see it right there. But theoretically, it just say, well, if I have more people, I have more information, I can be have more information, I can be more precise on the true answer.
Wait, I thought it was the opposite. Wait, never mind.
No, it goes that way. As n gets higher, the confidence length of the confidence interval gets shorter. All right, so we went. I didn't assign this, but some people did it. How many did it? I saw Dan did it, Ryan did it, and Bree did it. I didn't assign the second one.
I think Ryan did some of it.
I did most of it.
Okay,
You
all
can
right,
be more precise with the larger sample.
right. So it's going to shrink the confidence interval. You're going to be closer to that true
You're
answer.
more likely going to get the mean of the parameter in a larger sample.
This quiz 8.2 homework.
All right, so let's see. I have a choice. We can do this now, but since some people have done it and some haven't, I think I'll hold this off on this one till tomorrow. So if you have done 8.2a, then you are done your homework for tonight. But it was my goal to assign that one tonight, and the rest of the day we'll do some multis practice.
Okay. So 8.2.
So finish this 2-paper packet for tonight. And here's some multis so we can always use practice on. And tomorrow we'll do that other one. So make note. All right, this is chapter 8 multis.
I have one for Haley.
Oh yeah, that's thank you. And it already has one. Alright, I'd like you to try the first 3 by yourself as if you were taking the test. So put on the stress level you need for that. And go ahead and do the first 3.
Should I turn this off?
I think it'd be good because then at the end we'll just show them all the answers. That'd
Okay.
be good. So somebody take good notes on their paper, not only circling the right answer. All right, well, you can turn it off.
Not yet.
All right, we're gonna turn it off and we're gonna show you the answers to this multis exercise when we're right at the end of class. All right? Go ahead.